Have you ever wondered why we have seasons? Why one part of the year is warm enough for swimming and another is cold enough for heavy coats and hot chocolate? It's one of the most fundamental rhythms of our planet, the slow, predictable change from summer to winter and back again. But what actually causes it? Most people have a very logical sounding idea in their heads. They think that during the summer, the Earth must be closer to the sun, and in the winter, our planet must be farther away. It seems to make perfect sense. Closer to the fire, you feel warmer. Farther away, you feel colder. This simple explanation feels right. It feels intuitive. It's the answer many of us learn and accept without a second thought. But this seemingly obvious answer is completely wrong. And the real reason for the seasons is far more interesting and elegant. To understand the truth, we first have to talk about Earth's journey around the sun. This journey is called an orbit. Many people picture this orbit as a long, stretched out oval, with the sun way off to one side, a path that would bring us very close and then send us very far away. In reality, Earth's orbit is very close to a perfect circle. While it is technically an ellipse, it's so slightly stretched that you would barely notice. This means the distance between the Earth and the sun doesn't actually change that much throughout the entire year. It's not enough to create the difference between a scorching summer and a freezing winter. Here's the part that truly shatters the misconception. The Earth is actually closest to the sun in January, in the middle of winter for the northern hemisphere. And it's farthest from the sun in July, during the peak of summer. So the distance theory isn't just a little bit wrong. It's the exact opposite of what happens. If distance isn't the reason, then what is? The secret lies not in Earth's path, but in its posture. The real hero of our story is the Earth's tilt. Imagine an invisible line running straight through the Earth from the North Pole to the South Pole. This is our planet's axis. It's the line our planet spins around once every day. Now, this axis isn't standing up straight as it orbits the sun. Instead, it's tilted. It's leaning over at an angle of about 23.5 degrees. This tilt is the most important factor for our seasons, and crucially, this tilt stays pointed in the same direction in space as the Earth makes its year-long journey around the sun. Let's imagine the sun is a giant flashlight in the center of a room, and you are holding a small ball representing the Earth. As you walk in a circle around the flashlight, you keep the ball tilted in the exact same direction. You don't change the angle of the lean. Part of the year, the top half of the ball, the northern hemisphere, is tilted toward the flashlight. The light from the flashlight shines directly onto this top half. The beams of light are concentrated, focused, and powerful. This direct, concentrated energy heats the surface up much more efficiently. This is summer. The days are also longer because more of the hemisphere is lit up as the planet spins. Now, keep walking around the circle. 6 months later, you're on the opposite side of the flashlight. Because you kept the tilt pointed in the same direction, the top half of the ball is now tilted away from the flashlight. The light hitting the northern hemisphere is no longer direct. It comes in at a low, shallow angle. The same amount of light is now spread out over a much larger area. Its energy is diluted and less effective at heating the ground. This indirect, scattered light is what causes winter. The days are shorter, and the temperatures are much colder. Meanwhile, what's happening in the southern hemisphere, the bottom half of our ball, it's experiencing the exact opposite. When the north is tilted toward the sun and having summer, the south is tilted away, having winter. And when the north is tilted away in its winter, the south gets that direct, concentrated sunlight and enjoys its summer. This is why when it's summer in the United States or Europe, it's winter in Australia and South Africa. The seasons are always opposite in the two hemispheres. What about spring and fall? These are the transitional seasons. known as the equinoxes. They happen at the 2 points in Earth's orbit, where the tilt is sideways relative to the sun. Neither hemisphere is tilted toward or away from it. During these times, both hemispheres receive a similar amount of sunlight, and the length of day and night are nearly equal all over the world. These moments of balance give us the mild weather of spring and autumn, as we transition from one extreme to the other. It is not about how close we are to the sun. The seasons are caused by the angle of sunlight hitting the Earth. Direct, focused light delivers a lot of energy and creates warmth. Indirect, spread-out light delivers less energy and results in cold. The Earth's constant 23.5-degree tilt is the mechanism that changes which part of the planet gets the direct rays and which part gets the indirect rays. Our planet's simple, elegant lean is the engine that drives the entire cycle of life, from the budding of flowers in spring to the deep slumber of winter. Here is a simple way to remember it. Think of aiming a garden hose at the ground. If you point the hose straight down, the water hits a small, concentrated circle with a lot of force. That's summer sunlight. If you spray at a low angle, the water spreads out weakly over a large area. That's winter sunlight. It's this hidden geometry, the silent, constant tilt of our world, that paints the beautiful and ever-changing masterpiece of our seasons.